Yes, we are preparing students for jobs that don't exist, using technologies that have not been invented to solve problems that have not been identified. Again, we are preparing students for jobs that do not exist. Why does she says that? Because there is a major evolution of how auditing and how advisory services on firms are going to exist. And they are going to prepare specialists. Now, this is something we didn't talk yet about, but there is going to be, no question, a displacement of accounting jobs and auditing jobs. Most of the write-up jobs that low-end accounting does are basically already disappearing by ERPs and by software and et cetera, et cetera. No one knows if there'll be more people employed by the industry or less in 10 years. Okay, there's going to be a migration of functionalities. And what this migration is going to be is very difficult to predict. My personal impression is that the profession is going to evolve, is going to be much more analytical. I think our curricula in accounting are going to have to be dramatically changed. Just for your information, if you haven't heard this from Professor Sanella, there is tremendous pressure by standard setters, by professional associations, and by leading accounting programs to add much more analytics in the programs. So introductory accounting, intermediate, advanced, auditing, they're all going to have computers, they're going to have spreadsheets, they're going to have analytics in them. And we are, Professor Sanella, for his new book, he's going to be developing electronic exercises, and I'll be very surprised if he doesn't use it in your classes. But that's kind of a change in the profession. The other interesting thing that's happening is at the moment of the pandemic, there is a major compression on advisory. I think in Australia, I was told that about 20% of the business basically disappeared. And so, but when they come back, it will come back different. It will be different services, evolution of the business. And then the other thing is the technologies that have not been invented are basically things like we are doing in AI and et cetera, that progressively are being developed. And the problems of the 21st century company are going to be problems that are very different from today. And, you know, if I would be teaching this course 3 months ago, 4 months ago, I wouldn't talk with so much confidence. But observing what had been happening in the pandemic and how business has been reacting to the pandemic, I am pretty sure at this moment that there'll be substantial changes on how we practice accounting, how we practice auditing, and what kind of services our advisory services will present. And tomorrow, next time, we are going to talk a little bit about what already have been observed, what I already observed, and what maybe you have observed. Okay, so this was the Heller Glazerman's chart. And I'm going to talk a little bit about something a little bit more theoretical. And these are the slides of an extraction of a book. And this is what I was mentioning before. This is actually 3 professors of the University of Toronto. But interesting enough, when you hear about people talking about AI, people typically are techies. And these guys are not exactly techies. They are people, they're economists. And the frame is economic framework. And I think it's very useful. And I wanted to start with this. And then, of course, we are going to also take a techie trend eventually. So this is the book is called Prediction Machines, and is published by the Harvard Business Review Press. And it's actually three authors. And interestingly enough, the book here, they only say one author, which is A.J. Agrawal. Okay, so let's go for this. The perspective from economists. The current wave of advance in AI doesn't actually bring us intelligence, but instead a critical component of intelligence prediction. And that's really the emphasis. The emphasis is on analytics to predict. And then there are other components of the business process. Prediction is a central input into decision making. Economics has a well-developed framework for understanding decision making. The new and poorly understood implication of advancing prediction technology can be combined with the old, well-understood logics of decision theory from economics to give us insights. And then he said they talk about there is often no single right answer to questions on strategy. And because using AI involves trade-offs, speed, accuracy, autonomy, control, quantity of data, and privacy. Okay, let's just go to each one of them. Speed. Most decisions that are automated are much more expeditious than decisions that are manual, and also they are typically much more consistent. So when we do robotic process automation, or we do automation itself, you finish up with a more restricted set of movement, meaning is either this or that, and a much faster decision, much more consistent. Now, consistency, we always say consistency is good, we don't create errors, and et cetera, et cetera. Consistency is good sometimes. Sometimes innuendo would say that some inconsistent decisions are better. So that's something that needs to be considered. And then the next thing they say here is less accuracy. That's not necessarily correct. Could be more accurate, could be less accurate. Very much depends on the process itself, the situation itself. Let me give you an off-the-cuff discussion here about AI on just one line of thinking here. Over the years, we have started developing all these analytic models, which we now together call them machine learning. And what is machine learning? Is basically using archival data to predict what's going to happen. So the classic ones are, for example, looking at stock data and predicting what's going to happen with the value of the stock. Okay, so this is what we call supervised machine learning. Does it mean supervised machine learning? You have an outcome, you have inputs from history, and then machines develop a formula that link one to the other. Not too far in the future, there is going to be a device that you are going to be able to buy and install as an app to your iPhone and etc. What this device is going to be is going to be a formula that you take a picture of your skin. You have a little mole on the skin, and it'll tell you if this mole is cancerous or not. Great application, very useful. Save your visit to the dermatologist. Maybe a little bit dangerous because it doesn't depend on the dermatologist. But how did they develop this device? How do they develop this formula? Well, they pick up 800,000 diagnostics of moles that a large number of dermatologists did. Look at the evidence that the dermatologists had and link the evidence by doing deep learning or applying a couple of different machine learning technologies and come up with a formula. And that formula will give you a probability that that mole is cancerous or not. And the designers of the app will decide that above 80% is cancerous, below 8, or might give even the probability to the user. Okay, I don't know what the user is going to do with the comment, this is 40% likely to be cancerous, okay, or 20% or 5%. So I don't know exactly how they are going to do that. But what is that? That is historical findings and diagnostic by individuals. Is that better than a dermatologist? Well, it's about the equivalent of the average dermatologist. Some superstar dermatologists hit it more on the head. The bad dermatologists make bad diagnostic. But in average, this is what this machine is going to have. So a supervised machine learning device basically, by a set of algorithmic methods, comes up with a prediction, which is a formula. And now you take it out of that domain, take a picture of your skin, create a new set of the data, plug the results of the data into the formula, and you get a number. That's the way it is. And same kind of thing with stocks. Stocks, the price of the stock changes. That's the outcome. And the different things, competition, this and that, create other evidence that the analysts use. They link one to the other, come up with a set of formulas. So that's kind of machine learning methodology. And of course, there are many variations on this, and I'm oversimplifying this substantially. Now, at this moment, we actually are going to have a problem with machine learning, for example, in stock prediction or something like that. Why? Because there has the history of economic events that bases many of the machine learning methods don't apply in the age of pandemic. Something very different is happening. We don't have a lot of experience. Maybe in some angles we do, in some angles we don't do. So it's always have to think about the way you interpret this. The other things that just continuing here, continuing here. So it can be more accurate, can be less accurate. It can be totally autonomous, meaning a formula determines something to happen. It could be if the formula doesn't give you the results you want, it calls attention for a human to get involved. Now, the moment you put formulas to decide things for you, you lose some control. And then this whole environment requires data, requires large amounts of data. And if you look at machine learning algorithms, they actually are notorious to be inefficient with data. They require a lot of data for certain decisions. Children learn faster than machine learning algorithms in things like identifying objects, identifying sounds, remembering sounds, and etc. So we are pretty far away from certain devices being superior to humans in certain functions. And I usually don't like this whole discussion of machines being smarter than people. I typically usually say to that, machines are much smarter than you to multiply. They can multiply 10 digits by 10 digits in a millisecond and be right. Would take you an hour to do it if you could do it. The machines can retrieve 1 million lines from 1 million lines of code or from 1 million lines of data, a particular data set, see, a data that is there. Okay, so they are much smarter than you on that. But in many other things, a machine that cannot match a child in many things that they do. So, I don't find this particular discussion particularly useful. I also, I don't even like very much the terminology of intelligence. It's basically capabilities to perform a task. And if Jennifer 20 years ago would have seen an iPhone as today, an iPhone 11, she would say, this thing is very smart. It knows where my car was parked. It knows what traffic I should take. It knows what I should eat to be healthy. It has all these functions. This is really artificial intelligence. No one today, or not too many people, pick up their cell phone and say, oh, that thing is AI. It's functionality. You have to think in terms of functionality. What functionality are being provided? Now, the other side of the coin of the nature of this functionality and how does it compare with human in the application to something is worthwhile studying and thinking about it. And all of you are going to be in your careers making decisions like, do I use the software or I hire a person to do this? Do I hire the software firm to develop an AI algorithm, or do I hire Abby to do a robotic process automation here, or I leave my staff doing this? And you're going to be very dollar driven. When it comes out to everything is really what is the economics of this stuff, and what is the quality that you provide to the client. Okay, I'm going to go to the next slide. And basically what the authors here talk is about the trade-offs on the AI economy. And some are very obvious. More data means less privacy, meaning people, I am always very nervous about putting my personal pictures on the cloud. I really, my grandchildren, my family life, it bothers me. And this is not rational. Everyone else does it, and does, at least this moment, there is not too much problem. But some people think one way or the other. And as I said, the young generation is much less worried about privacy. And this is also cross-cultural. I think Chinese citizens are much less worried about privacy than American citizens because of the way life is there. Okay. Then the next one, more speed means less accuracy. I'm not sure if I agree with what they say. Okay. Repetitive RPA processes perform very rapidly, probably are more consistent than manual processes. Would you say that, Abby? That certain parts of the audit, like you RPA part of the pension audit, wouldn't that be more accurate than individuals doing that?
Yeah, I don't understand more speed means less accuracy. I would say you can achieve speed as well as accuracy.
And what I usually tell Abby, and I tell many of my students, is don't worry too much about how fast the automation is, because you can always buy a bigger computer and you wait 5 years, machines will be 10 to 100 times faster. And so it's the current speed that your laptop does something is not really an indication of anything. And of course, if it's useful enough, you can always throw cycles at it. But the last one, I tend to agree. More autonomy means less control, meaning you have much less control when devices are performing the functions you like. So going back to these trade-offs, privacy is reduced. Accuracy, in my opinion, actually is increased. There is certainly less control. Okay, so Steve Hawkins said everything that civilization has to offer is a product of human intelligence. Success in creating AI would be the biggest event in human history. And I'm not totally sure about that either. First, I don't totally agree with this terminology AI. Abby is a recent entrant since she was born in the technology world. I have been here since first computers were introduced in Brazil. And so it's a long time. And what you used to call computers and science broke down into many, many, many little fields: networking, cloud computing, etc., etc. And I think what we call today very vaguely AI is going to be a whole set of narrow domain applications. And I actually I see the firms investing big bucks on things like bad debt detection. Okay, so basically estimating loan losses in banks. Um, and they capture a lot of data, they scan the data, take it out of PDFs, run machine learning, etc. Big expenditures, etc. I think the little AI that you can use today with narrow little apps that you buy to count things, to identify vision things, and etc., is really where more benefit uh, will be accrued. It's a whole set of how to think about things, um, and how to evolve things. Um, and again, the concept of artificial intelligence is kind of a bad concept in general. Um, okay. Um, Now, the role of prediction, that's kind of very interesting. And I don't think you kind of notice that so many things that you do is there has a prediction component. You are driving a car. There is a car coming in your direction or crossing the street. You immediately are predicting if their path is going to match your path, is going to be a collision or not. Okay? And you see an object on a shelf, you predict if it's going to fall. If you go in a supermarket, you predict if you have money to buy a certain thing or if you are going to use it, and etc. So this thing of prediction, and that's why I like this particular book, the emphasis on prediction is really something that has not been very well discussed in the terminologies and in the methodologies of research. We had a PhD student, and Sivi Pan, with a very long Thai name, and she did actually a predictive audit dissertation. It was quite interesting, using prediction algorithms to better identify fraudulent activities, better identify where to focus your controls, and etc., etc. So actually this idea of prediction has been tremendously neglected. If you look at this slide, they talk about some of the mathematical statistical techniques that you use and say, much discussion about the AI emphasize the variety of prediction techniques using increasingly obscure names and labels: classification, clustering, regression, decision tree. And these things, by the way, you are going to know what they are by the time you are done in this course. Now, the other ones, Bayesian estimation, neural networks, topological data analysis, etc., maybe a little bit less, okay? However, these are basically statistical techniques to predict. And basically, when the economist views, economics offer clear insight regarding the business implication of cheaper prediction. And that's actually very, very interesting because, you know, you can buy devices for predicting. For example, you can buy sophisticated navigation devices. You can buy AI tools to execute strategy. And there is really basically a trade-off. For instance, if Amazon can predict what shoppers want, then they may move from a shop then ship model to the ship then shop model, which is what Abby was talking about Amazon. Now, this is a kind of boogaboo that they talk all over this book, talking about Amazon sending things to your house before you buy them and accepting them to be returned if you don't want it. Abby showed you this model, which is a little bit different because the model you pay a fine in one sense if you actually return it. But it's kind of the same thing. If prediction gets good enough, you're going to do things differently. And that's actually very, very interesting thing to think. I don't I don't take very seriously the idea of Amazon flooding my house with stuff that I haven't bought. But I think that the way of thinking about this is actually a very interesting thing to think about it. And it's probably worth expanding. Finally, as a result of new strategy organization pursued to take advantage of AI, we will be faced with a new set of trade-offs related to how AI impacts society. Our choices will depend on our needs and preferences, and will almost surely be different across different countries and cultures. We structured this book in 5 sections, and this is the way they divide it. And actually, the 3 first one are the ones that I'm going to talk more about. Is mechanism of prediction, and they separate prediction to decision making. And prediction is thinking about and evaluating what's going to happen. Decision making is under those circumstances, what would I do? That's the decision making. And then the third part of it is what tools I'm going to use to make predictions or to automate my decision making. And then the other 2 parts of it are really company-wide strategy, which we are not going to talk too much about, and the effect on society, which we are going to talk a little bit about, in particular about pandemic and the effect of technology in the pandemic. So these are the kind of 5 pieces that are worth talking: prediction, decision-making, tools, strategy, and society. And I have here the kind of 2 illustration of prediction and detection, and I want to just read them to you. Predict whether a current credit card transaction is legitimate or fraudulent, whether a tumor in a medical image is malignant or benign, whether a person looking into the iPhone camera is the owner or not. Okay, the first one, current card, credit card transaction. That's kind of a phenomenon we are very used to. You go to a place, buy something using a credit card, all kind of things can happen. Transaction small enough, probably no verification happens. Transaction is large, there'll be some kind of machine learning, in this case, actually expert system, creating where is this thing, what kind of buys you typically made, do you make buys of this side, what is the geography, meaning if you live in the United States and this is a transaction in Transylvania, you're going is going to be rejected, etc., etc., etc. So there are these algorithms in all the credit card companies that basically have rules about predicting if a particular credit card transaction is valid or not. And then there are these decision rules of trade-offs, meaning if I don't approve this transaction, I will lose my commission, which could be between 2 and 7%. That's one part of it. However, if I rejected it, I also might lose a client because the client will be very upset that when he needed the card, he didn't use it. So that's kind of mixing. Prediction, if this is 98% likely to be a legitimate transaction, I will certainly approve. This is 70% likely to be a legitimate transaction. Maybe I'll accept or not, depending if this is a good client, if the patterns of behavior of this acquisition are common, then maybe I'll approve it, maybe I don't approve it. Now, on the other hand, in a problem like looking at the tumor, the stakes are much higher. The stakes of someone's health, and there maybe there is a whole human machine interface whereby this is for sure not malignant. Nothing happens. This is maybe malignant. You call a doctor to have a look at it. And so you kind of create a man-machine interface to help. And maybe the doctor will be 2,000 miles away. You won't need local people examining medical images. Now you can transmit it across the world, and you might have specialists. One is a breast cancer specialist, the other one is a lung cancer specialist that can identify better these particular images. I go back to my dermatological example, and those predictions of skin cancer are based on a large population of dermatologists. Some of them are excellent dermatologists, other ones are just run-of-the-mill dermatologists, some of them are bad dermatologists. And at this time, they don't create these models only with an excellent dermatologist. They don't even know who are the excellent dermatologists or not. However, when the stakes go higher and higher, there is more specialization, and you expect to have better decisions. Now, I have a set of slides that I typically use, and I talk about man decision or human decision versus machine decision. And there, in human decision, I say humans are inherently biased. And in a series of regression tests, typically machines perform better than the average human. Now, that doesn't apply very well to very narrow specialties. And there has been less meta-analysis on this. What is meta-analysis? Or analysis of many research to get some kind of common decision. Okay, now going back to detection, credit card fraud detection has improved so much that credit card companies detect and address fraud before we notice anything amiss. You know, this happened to me the other day before we were locked out from the pandemic. I was in an airport and I tried to buy something with a credit card I don't use very much. And before the lady was deciding on my sale, I got a message on my cell phone saying, "Is this you?" So actually, this was the first time that I had an interactive experience in a purchase. When I said yes, the sale was approved. It was a small one. So I don't exactly understand what are the economics of doing that. But very, very interesting understanding real-time technology, prediction algorithms, and economics. This is the economics are the decision-making factor. You predict 90% this is a valid transactions. Then you decide, does Miklos is in a transaction of $20, is it worth to reject the transaction or not? It's a whole different set of things. And what this thing here talks about is the rates of prediction on credit card improved to 95% in 2000 to 99.9% today. That last jump is a result of machine learning. The change from 98 to 90% have been transformational. What does he mean by that? Being transformational, meaning now you can really use this in many, many type of things, and you can pretty much automate it. And I just want to finish up with a quote by Varian. And Varian is like one of the grand old men of the internet. And he was a professor at Berkeley, and he's now the chief economist at Google, or he was, don't know if he's still there. And he said in 2003, 1 billion hours ago, modern Homo sapiens emerged. 1 billion minutes ago, Christianity began. 1 billion seconds ago, the IBM PC was released. 1 billion Google searches ago was this morning. And this basically said how much data is there. And we are going to have this discussion about data being the new oil. And, if you look 10 years ago, the value of companies, maybe 15 years ago, top companies in the New York Stock Exchange were Exxon, Mobil, all the oil companies. Today, what are the top valued companies? Google, Apple, etc., etc. The oil companies are not even close